So I will start the program. Respected today's speaker and great personality, Dr. Sydulu M, Professor, Electrical Engineering, NIT Warangal. My dear faculty members and my dear student friends, good morning to one and all. Today we are gathered here for the procuring the knowledge on prospects of electrical engineering in modern power systems by today's speaker. And now I will give some talk on briefly on the responsibilities of electrical engineering students. So now, what do electrical engineers do? Electrical engineers works in a very wide range of industries, and the skills required are likewise variable. These range from basic circuit theory to the management skills required of a project manager. They apply the physics and mathematics of electricity, electronics, and electromagnetism to both large and small scale systems to process information and transmit energy. To do this, electrical engineers design computers, electronic devices, communication systems, test equipment, electric power networks, and improve systems through problem solving techniques. The tools used equipment then an individual engineer may need to similarly variable ranging from a simple voltmeter to a top-end analyzer to sophisticated design and manufacturing software. The job duties of electrical engineers depends on the industry, where one is carrying out feasibility studies for new technical developments, drawing up project plans and circuit diagrams, usually computer assisted engineering and design software, then estimating cost and project timings, then coordinating the work of technicians and craft peoples, testing installation and systems and analyzing test data, making sure projects meet safely regulations, attending meetings, writing reports and giving presentations, and some skills are required each and every electrical engineering student. So one is they can know the circuit designing, instrumentation and electrical measurements knowledge, power transmission and distribution line fundamentals, electrical drives and electrical machinery, power electronics knowledge, renewable energy fundamentals, microcontrollers and programming languages, presentation and communication skills, fundamentals of electrical power generation and maintenance of electric power plants, control systems and control machinery, then quality control and analysis. So these all the important things will be going to require each and every electrical engineer. So now the time for introducing our today's resource person, Dr. M. Sydulu sir. Is very senior professor in NIT Warangal. So great personality, sir. So now I would like to invite Sivadipti madam to introduce today's speaker, Dr. M. Sydulu sir. Thank you, madam. Thank you, one and all.
Sir, good morning, sir. Is my audible, sir?
Okay, madam. Audible, madam.
Yes, sir. Thank you, sir. So, good morning to one and all. Welcome to all the participants for today's program on prospects of electrical engineering in modern power system. And it is my honor to introduce today's resource person, Professor Sydulu Maheswarapu sir from NIT Warangal. And sir was born on October 1956 in Kami village in Khammam district in Telangana state. Sir received bachelor degree in electrical engineering in the year of 1978 and MTech degree in the specialization of power system in the year 1980. And sir awarded PhD in research area in the year 1993. All three degrees are from REC Warangal, that is presently NIT Warangal. Sir joined as teaching assistant in REC Warangal in the year 1980 and served as a lecturer in RECW during 1981 to 1993. And as an assistant professor in RECW during 1993 to 2003, and as a professor from 2003 to till date. Sir served as head of electrical engineering department from 2004 to 2007 and also president of Teachers Association in the year 2008. Sir also worked as Dean of Administration from 2008 to 2009 and Dean of Research and Consultancy from 2009 to 2010 and Dean of Faculty Welfare from 2014 to 2016. So Sir has totally 40 years, 2 months teaching experience at RECW Warangal. Sir was also a member of UOG of NIT Warangal from March 2021. Sir taught a number of subjects in electrical engineering, such as advanced computational methods in power systems, state estimation and security analysis, economic operation of power systems, power system deregulation and real-time control of power systems, power system operation and control, power systems 1, power systems 2, circuit theory 1, circuit theory 2, and control systems. Sir, under the Sir guidance, under the supervision of Maheswarapu sir, 17 research scholars awarded PhD and 3 scholars are presently working for their PhD. And also sir has guided 65 MTech projects and 50 BTech projects. Sir also published about 44 papers in international journals and 75 papers in IEEE international conferences. And Sir bagged POSOCO Power System Award, that is PPSA 2013 and 14 awards for Best MTech Thesis and also Best Engineering Faculty Award in 2015. Sir worked as consultant to M&N Dastur in Calcutta, Global Energy Consultant in Hyderabad, Vizag's Plant System Studies, and also for Ramagundam Township Distribution System Studies. And also Sir worked as consultant to 40 major lift irrigation projects of Government of Telangana and AP. Sir has a lot of interest in the research areas of real-time power system studies, distribution system studies, artificial and meta-heuristic technique applications in power system, smart grid and renewable energy resources. So it is very glad to have Mr. Sydulu Maheswarapu sir today as our speaker, and we all should grab this opportunity and learn many things from this platform. Thank you for giving this opportunity. Thank you one and all. Thank you, sir. And it's over to you, sir. Thank you, sir. Hello, sir. Hello.
Hello, sir.
Yes, sir. Hello, sir.
Yeah,
Yes, sir. Okay, sir. Okay, thank you, sir.
yeah. Then, can I start?
Yes, sir.
Yeah. Very good morning to all of you. Thank you for giving this opportunity to share some of my views on prospects of electrical engineering in modern power systems. I thank the head of the department and madam for taking time to present my biodata to the audience. I believe the presentation is going to be useful to the friends who are in BTech level and MTech level, maybe of the teachers who are offering the courses for our BTech students. I'll be sharing my screen. If the screen is visible,
Yes, sir. Yes, sir. Visible, sir. Sir, screen is visible, sir.
yeah, that's
Yes, sir.
okay. That's so. The today's topic is of prospects of electrical engineers in modern power systems. The content could be in this order because I'm trying to really address my electrical family children. So I'll be just speaking some of the fundamentals which are very much required to make ourselves to be potential in modern power system. So first topic, maybe 5 to 6 minutes. It could be of basic electrical engineering aspects, growth of electrical system, how it is really grown, and then a modern power system, various areas of electrical engineering and job opportunities to the triple students. Every person is gifted with 2 hands. Why 2 hands? Nobody knows. If I ask to show your right hand, you will show. Why it is called the right hand? You don't know, I don't know. Why you are blessed with only 2 hands? We also don't know. But what right hand can do, what left hand can do, we know. So in electrical engineering, I will be requesting all of you to look at your both the hands and try to learn how these 2 hands can help us to understand the basic part of our electrical engineering. Right hand one, that's going to represent the electric flux, and left hand is going to represent the magnetic flux. Entire electrical engineering is having only these 2 fluxes. We don't have anything more than that. So if you look at both the hands, you can easily remember what the 2 fluxes are there in electrical engineering and how we are really getting the benefit of these fluxes and trying to make the system as big as a modern power system level and trying to make the country to be advanced country. And look at your right hand. My family is having only 5 members. Electrical family is having only 5 members. Yeah, it's in a little finger, you can say it is a resistance. And your ring finger, you can say it as an inductance. And the third finger as a capacitor, middle finger. And fourth finger, you can say it is a current source. Then the fifth finger, that is a thumb, it's a voltage source. So you can have this very easy to remember, R, L, and C, and then this is current source and voltage source. And those are the friends who can really know the characteristics of what R does, its behavior during the transient, during the steady state, and in AC network, in DC network, how it behaves. If the student can learn at first year level, I believe you will be gifted with so much of fundamental concept for rest of his learning, not only up to BTech level, rest of his life. What inductor does during the transient behavior or transient period, and what is called steady state period in AC, in DC, what is the fundamental nature, and then capacitor similarly for AC as well as DC, and what current source, where exactly we come across, and maybe after a very few occasions we try to show that, but for a relay testing and other things we try to put them. Voltage source, it is the one, a father figure for the entire electrical engineering family, and it is the one which is going to make you to have the best benefit out of it, and you have different type of generations also. So please always look at your right hand and say that 3 children, 2 parents, and try to really make the entire system to be so much coordinated, cooperated, controlled, and finally discharging the given responsibility of supplying the electricity for the citizen in the modern society with the following characteristics. What are the characteristics? Your left hand, you can remember, your left hand can say the what are the indices you are requiring for to be a very quality supply to the consumer or customer. That is also going to be of a constant voltage. Constant voltage is very much required for us. It indicates the healthiness of the your supply, and If the voltage is very poor, induction motor gets burned. If a over voltage is there, equipment gets burned because of insulation problem. Constant frequency, it is of stability aspect, rotor angle stability aspect. Unless the frequency is maintained well within the specified limits of now. Nowadays, it is going to be very rigid limits are there, constant frequency. And third one is the uninterrupted power supply. This is the order of the day. If you don't have power, I think any time a similar pandemic situation is there in 1980, simply college would have been closed for 2 years. Nothing would have been done. But now, because you are blessed with so much of uninterrupted power supply, communication aspects, computers, whatnot, you are gifted. I am also gifted. That's reason I could address you people on online, sitting almost maybe of 200, 300 kilometers away from you. Uninterrupted power supply. This is the very much promising component or of quality that is required. And low cost. You have to look for the low cost. There's a fourth finger is going to be low cost. For example, the solar happened to be started with 17 rupees per kilowatt hour, and only research was going on that, and only some laboratories could have the chance to establish that some solar panels and try to conduct some experiments and get some PhD work done on that. But now the cost of the solar per kilowatt hour has come down to anywhere up 2 rupees 14 paisa. It's a bidding price is now 2 rupees 14 paisa level. And our college got 1 megawatt, it is of 2 rupees 49 paisa agreement. If the actual 17 rupees all is there, neither Prime Minister nor you nor as a professor I can say anything about it, and it will not really be useful to the society. So any technological development must be with low cost, and it is the responsibility of the researchers and companies, industries to see that some good work is done and people get the best to the benefit of these citizens of India or the world. And smartness, yes, this is the you people are in the smartness area, and without smartness neither you can be successful nor my power system can be successful. Lot of information is to be passed on, stored, analyzed, and then reports, whatnot. Everything has to be done with the help of communication network, with the help of computers, and real-time monitoring, operation, and control is the order of the day. For example, near to our Warangal Mulgu substation, there is what is called 400 kV substation owned by the Power Grid Corporation of India Limited. And so everybody is to be given the connection, and this is going to be very Herculean task. Now, suppose the government says that keep energy meter at every agriculture pump connection, I think it is going to be very difficult, and they want to have the bidirectional communication. I don't know whether it is possible or not. At least in India, I have my own doubt about that. Now, what are the other technologies which you are going to trying to them? This is another version which you are going to battery storage technology. This can help you in a big way. And when you go for the actual solar and wind and other things integrated with your modern power system, inertia constant is going to be very low. Very interesting observation is here. That's often I can just recently, of course not recently, 1 year back I visited Ramagundam thermal station, where almost 30-40 of my own BTech MTech students are available. We gathered and we had some discussion. I asked, when the solar is pumping so much of energy during the sunny day, how exactly you are operating your so much of 2600 megawatt capacity is available? Are you going to pump, or you are taking measures to really do anything with that? So they are asked to really ramp down to the level of 400 megawatts per minute level. And the excess amount of solar is there, and they are forced to run a plant load factor less than 57.7%. And if the plant load factor is going to be lower than that, usually they are having Asian record. Bajarla thermal station, Ramagundam thermal station, they are having the plant load factor almost 0.9 to 0.93 level, or even to 0.98 also. But now they are forced to cut down their generation forcibly. Reason is somebody is actually supplying with low cost, and here you are having the possibility of effective generation, but you are not permitted because frequency goes more than the specified value. So then you have to cut down. Then I asked, now, do you have the normal behavior for the what's called boiler. So they said that not to have the functioning of proper functioning of boiler, they have to fire with a special fuel. Special fuel is very costly compared to the regular fuel. So therefore, it is something like very unusual thing is going on with penetration, high penetration of your solar and wind into the grid. And I think when you have the storage facility and with effective storage and monitoring and then maintenance, I think the combination of these two can make the system to be of viable in future with all facilities. Then optimization of land plants and 100% utilization of ash and coal. This is the getting attended, and you can have that. Gas insulated substations in Ramagundam, I have seen gas insulated substation is going to take almost 1/6 of the area of that is required, not even 1/6, even less than that of the area that is required for a conventional substation. So GIS, I have seen one gas insulated substation at Ramagundam, other near to the Usmania Engineering College, where both the places my own students have taken me around. Multi-circuit towers, and I will show you some figures of multi-circuit towers. And now that suppose I want to have a corridor, most of you know that corridor means the place or the land you are used for erecting the transmission towers, and running almost, for example, Varsha to Bangalore, there is a 1400 kilometers distance. Such a line you want to, that is 765. You can need 80 meters or so the width of the corridor. So it is going through so many agriculture lands, and then you have to pay the money for the farmers. And acquiring the land becomes very, very expensive. So then better we have the reduced corridor, and how to really use a big circuit on the same tower. And we must thank the civil engineering people who are trying to help a lot. And they have designed good towers which can withstand multi conductors on the same tower. I'll show you some figures. So then this is the 1200 kV transmission line. Of course, in China you have 1100 kV. We have 1200 kV, and in future I believe many more big such transmission towers, transmission lines, as in the form of corridor you make it. And short circuit testing facility we should have. We don't have UHV laboratory near to Uppal. We have up to 765, but 1200 kV level we need to have indigenously. HVDC transmission is also up to 800 kV. And remotely controlled substations, numerical protection. Gone are the days of your what you call electromechanical relays and PMU measurements. And resin integrated paper bushings. Then means porcelain. A lot of research is going on. Porcelain insulators you can replace with this type of energy efficiency. LED lighting. This is another thing. Warangal, I have seen in Warangal. In fact, I have designed what is called central lighting facility, automatic switching on, automatic switch off. And those days they used to have mercury vapor lamps, and the cost of the bill per month is so heavy. And I designed a mechanism where after 11 o'clock automatically alternate poles will be having the lighting, other poles will be having off, and we save a lot of energy and we reduced the bill. And we also designed electronic chokes those days. And those chokes, and most of conventional tube light takes 40 watt, and that out of 40 watt, 18 watt is dissipated in your choke itself. And we wanted to reduce that 18 watt, and we designed, we were successful, and we got a chance to go for the implementing with the help of a collector in what is called hostels of the boys hostel. When we did not use the electronic chokes, the bill was of around 10,000 and odd. And after we used the electronic ballast, it was a 4,700 rupees. Huge amount of reduction was there in the bill. It is like save something while you spend. Energy loss in the choke we have eliminated. That was the thereafter lot of chokeless tube lights have come, and the LED lamping. This is also giving, but there is what's called I think you might have used CFL lamps. CFL lamps are going to have a lot of harmonics, and finally now people have said that don't use CFL. Compact fluorescent lamp. Kerala people, they have spent 2 crore rupees, and they have given the huge number of compact fluorescent bulbs to the one area. Everybody replaces that, and in the THD harmonic component is so big, and the actual so many laptops got crashed, and a lot of problems were there. And finally, they made a study, and they said don't use the CFLs. And we have an experiment in our laboratory to show the what is the harmonic component because of your switched mode power conversion supply of your computer, or of an LED or a tube light, all that we show to the students, saying that very clearly that LED is going to have low harmonic component, and then your CFL is having almost 80%. So then you can say that don't use CFLs. This of variable frequency drives, air conditioning technology, lot of star techniques are they are trying to, finally artificial intelligence, etc. Then transportation sector, these people are trying to now ask us to really have the chance of their geographical road structure and also optimal location of charging stations. One of my PhD students worked on this, where to keep optimal size of optimal location, optimal size of your charging stations. Yeah, now challenges. Skilling of people, that's now everything is growing. Like much before used to is, and theoretical people used to have a lot of hold. Now things have changed. Everything is coming up very fast in the industry and then in field. So the teacher and the students is not they are not having the skill, and also there are lack of skilled people. So skilling of people is important. Regulatory hurdles, PD clearances, this is in our country, show the man, tell the rule, and that unfortunate thing is going on. But maybe if they can really make speedy clearances, and we can have the lot of development, poor governance, investment climate, and then integration of renewable sources. This is going to be order of the day. I believe all the student friends should have the knowledge about this and integration of renewable sources into existing grid, and they can have some laboratory also on that. Adoption of new technology gradually, it is not overnight, it's not possible. You have to go for the new technology adoption and slowly. Protection of environment imperative. You don't have any chance, because ultimately you don't respect the environment. Finally, it's going to punish us, like with the pandemic situation. Stress on renewable sources, affordability, employment generation is must, because anything you do, finally you remove the employment for those people, and ultimately society is going to suffer a lot. And therefore the planning committee members, they will be looking at all these aspects, not only equation, not only cost effective component, they will be looking at about this thing. Yeah, I will give quickly the towers which I can show you. Yeah, this is the one diagram which you can show that all the regional grids are connected, interconnected. And for example, now eastern belt to the southern 3650 megawatt. And here the bidirectional flow is of Ramagundam to the, it is western region of 2700 megawatt. This western and eastern is of 7200 megawatt. So a lot of exchanges are going to be there. By 2022, they are expecting that 20,000 megawatt northeastern region to the eastern region, and then this eastern region to the southern region 15,000 megawatt. And here it is going to be almost 27,000 northern region. So this is the expected transfer. When you say that this much expected transfer is there, you have to build a huge amount of transmission networks. Without transmission network, it's not possible. This is the impulse generator. A friend has given that it's very costly at UHV laboratory Hyderabad. And this is the bundle conductors which are seen on blackboard. We write bundle conductor, bundle conductor. But these bundle conductors, I can walk the size of this. I can walk through this rings very comfortably, almost near to 5'8" my size, and I can walk through. That is the size of the bundle conductors of 765 kV. And this is a single circuit and power, and this is a double circuit of 765 kV line. And this is the bus bar arrangement. And on the blackboard we write a thick line and say that it's a bus bar arrangement. But now you can see it is a bus bar arrangement. And now you can just look at this 500 kV DC. It needs only 50 meters corridor. If you go for AC, both are equivalent in the same power transfer. It is of 85 meters only. So 35 meters width you can reduce. And then this is equivalent to 500 kV of 100 meters. So then corridor becomes a problem. In future, land becomes very expensive. Therefore, new technologies are to be used by us. These corona rings and different towers. Wherever I go, I take a photograph and try to show my friend. This is the one which you can see. Almost four circuits are there. The teachers who are teaching in power system 2, they say only double circuit also. This is one circuit, this another circuit, this totally 4 circuits are there in this on single tower. This is a six circuits are there. No textbook is trying to show the 6 circuits problem in a circuit textbook, but you can show that there are 6 circuits, 3 one side, 3 other side. Of course, it's up in 132 kV level. Then this is the one which I have collected in USA. You can see that only it's a double circuit. It's a double circuit, but you can see easily that this width is very hardly 5 meters. So therefore, corridor space is minimized, investment is reduced, and we will have the best benefit. And it is withstanding the wind gale of almost 110 kilometers per hour, that level. So this is the power handling capacity. I stop here. Last 5 minutes I have. That's you can see the 1200 kV. Average height is 21 meters, and the R is going to be this of low resistance, and then this is the X is reactance, and X by ratio is going to be. Teachers who are teaching power system operation and control, they should focus on this. X by R ratio is going to be the tan inverse of X by R ratio is going to be the angle which you can get. So if the X by R ratio is very high, it will be near to the 90 degrees. So then it will not really lose its stability, even if it is loaded beyond 70 degrees, 80 degrees. But then for a distribution network, X by R ratio is 1. The limitation is 45 degrees. So you can't load it beyond 45 degrees. And therefore, this X by R ratio is something like a big bang balance. And computer methods in power system fellows also can make a lot of observation on this. So with this, I'll stop, and all the modern features I have given you, and all my student friends can expect themselves to be of very potential with respect to their basic subject of electrical engineering, circuit theory, and then more of communication skills and their communication, easy communication subjects, and soft computing techniques and computer applications. Thank you for listening to me. I will now invite some questions from your side. Ready, Aru?
Sir.
Some questions from your side.
Right, sir. Hello, dear students. Hello, dear students. You have any doubts? Please ask, ma. Freely. Hello. Please ask.
Good morning,
Have any
sir.
doubt?
Yeah, very good morning, Sai. Yeah, Sai Jahannavi. Good morning.
No doubt, sir. It's clear.
Yes, sir. We are clear the idea, sir.
Anyone from second years? Dear students from second year, please ask any doubts. Hello. From third years? So it is not a one-way traffic, ma. It is I have to mutually understood all the concepts of electrical engineering. So if you have any doubts, please ask to the sir. Hello. From final year students, have any doubts? Hello.
No, sir.
Oh, okay.
Yeah, then I believe that there is a small apprehension with the student friends whether that person can be really good or not. Sometimes it happens, but you should have a chance. Always trying to really ask a question from fundamentally. I used to ask a question with my teacher that why you call your left hand is a left hand. And similar type of questions I used to get. My own student, his name happened to be R. Venkateswarlu, from a Telugu medium student. Rate of change of flux linkages induces EMF. I used to write on the blackboard. He used to note down very quickly, sitting in the first row, and ask him why. So this gentleman became YVLU. Instead of becoming R. Venkateswarlu, he became YVLU. He used to make panic with all the teachers, and then he started learning. Though Telugu medium student, he used to have one word of why, and he became class topper. Right now, he is a collector in Allahabad. Maybe
Sir,
as me, I moved to the service. That is a different domain. One can be around 60-70, for example, including CBI Joint Direct Lieutenant Gar is our NITW, DGP Mahendra Reddy Gar from NITW, Surendra Babu from AP is from NIT Warangal. We have good number of people from this police wing also. That's one can go to any collector side or till recent past that collector of Vijayawada is our own student. Mutual Raj, my own electrical student. You can if you search about Mutual Raj, he is the only boy who has taken electrical engineering as an optional subject, and he became the #1 in IAS. And he was from our electrical. I taught around 5 subjects to him, and he was the only person who got circuit theory 100 out of 100 in external. So that's
excellent.
And allowed to really seeing people growing in all domains of your interest. All the best, sir.
Sir.
Yeah,
Sir, okay, sir. I will continue, sir. Yes, sir. Yes, sir. Sir, today we are thoroughly enjoyed, sir, your presentation. It is in a very terrific and fantastic manner, sir, and enlighten our students as well as faculty members from basic fundamentals to recent technologies in power systems, sir. We thank your stimulating speech, sir. I am very grateful to your time of spending to our students, to enlighten our students. And
video, sir, at least I can see the people, 1 or 2 people. I have not seen anybody. Your video, then switch on your video also, so that we can.
Okay, sir. Okay, sir.
Know the only person by name, but not seen your.
Yes, sir. Yes, sir. No problem, sir. Yes, sir. Sir, no problem, sir. Sir.
Oh,
sir, myself, sir. Yes, sir. Yes, sir. Sir. So now I would like to invite Chaitanya Madam to present vote of thanks. Hello, Madam.
Yes, sir. Yes, sir, I'm here, sir. Sir, am I audible, sir?
Yes, Madam.
Sir, I take this opportunity to present vote of thanks for one-day guest lecture on prospects of electrical engineering in modern power system, organized by EEE Department, GPSET, Kurnool. First, on behalf of EEE Department, I thank our today's resource person, Dr. Sydulu Maheswarapu sir, Professor, EEE Department, NIT Warangal, for accepting our invitation from his busy schedule to grace the event. Sir has shared such a valuable information and guided the students and faculty members in various such aspects. I also thank our college management and principals, sir, for their continuous support in conducting various events. I also thank our HOD, sir, Dr. M. Ramprasad Reddy, sir, and IEEE coordinator, Dr. G. Panduranga Reddy, sir, for organizing such knowledgeable based events. I also thank everyone who directly and indirectly involved in making the event a grand success, and especially to the students for their active participation. So finally, thank you everyone once again for making this event a great success. Thank you one and all. Thank you, sir.
Yeah, thank you, madam. Thank you. Then I take leave from all of you.
Yes, sir. Yes, sir. Thank you, sir. Thank you so much, sir. Thank you so much.
Thank you so much, sir.
Thank you, sir.
Thank you, sir. It was a
Thank you.
wonderful
Thank
lecture.
you so much.
Thank you.